Look at the deep vacuum of space. It is entirely empty. No air, no water, no atoms to speak of. Yet light from a distant star travels across billions of light years of this absolute nothingness to reach our eyes. Throw a stone in a pond and ripples move because water molecules push against each other. Sound travels because air molecules vibrate. These are mechanical waves. They require a physical medium. Light is an electromagnetic wave. It survives the void because it doesn't rely on physical matter. Instead, it relies on a self-sustaining, coordinated three-dimensional structure. To see how this works, we need to freeze time, deconstruct this invisible anatomy, and map the mathematical blueprint that keeps the wave alive in the dark. Mapping this precise geometric relationship explains how every form of light and wireless communication manages to transmit its energy across the universe. Let's map this out in a vacuum. We start with a standard three-dimensional coordinate system. First, we plot the electric field, E. It oscillates back and forth in a smooth, sinusoidal wave, moving strictly along the flat plane of the x-axis. Next, we plot the magnetic field, B. This field oscillates along the y-axis, sitting at a perfect 90-degree angle to the electric field. While these two fields pulse up and down and side to side, they are both perpendicular to our third axis, the z-axis. This c vector represents the direction the entire wave is traveling. When you have an electric field, a magnetic field, and a direction of travel that are all entirely perpendicular to one another, you have a plane electromagnetic wave. This locked orientation describes a self-sustaining cycle. As James Clerk Maxwell argued, a time-varying electric field generates a magnetic field, which in turn generates an electric field. They regenerate each other as the wave propagates, allowing light to move forward without physical matter. If we unpause time, we can watch this geometric structure push forward through space. This motion is defined by two specific equations. The electric field on the x-axis and the magnetic field on the y-axis are both mathematically defined by their position in space and time. Look at the k in these equations. This is the wave vector. It dictates the physical shape of the wave in space. It equals 2 pi divided by lambda, which is the exact physical distance of one full wavelength. Then there's the omega symbol. This represents the angular frequency. It controls the timing, determining exactly how fast these fields pulse up and down every second. Frequency and wavelength are permanently bound together by c, the speed of light in a vacuum. If you increase the frequency, the wavelength must shrink proportionally to maintain that exact speed. Even their peak heights or amplitudes are bound by this constant. The magnitude of the magnetic field equals the electric field divided by the speed of light. The magnetic component is mathematically much smaller, but remains a mirrored partner. These equations confirm that the electric and magnetic fields are intrinsically bound mirrors of each other, maintaining strict mathematical proportionality as they travel. Everything mapped so far happens in a vacuum, but watch what happens when this wave crashes into a physical medium, like water or glass. The moment the wave enters material, it interacts with physical atoms. It can no longer travel at its universal speed constant. It slows down. This equation gives the wave's new velocity, v. It equals 1 over the square root of mu times epsilon. Epsilon is electric permittivity, and mu is magnetic permeability. Together, they act as a brake on the wave's forward velocity. Light's velocity depends on the specific electric and magnetic properties of the medium. Mapping this geometric anatomy provides the blueprint for how light waves bend and transfer energy as they pass from the vacuum of space into the materials of our world.